Ladies and gentlemen, good morning. It is definitely an honor and privilege to welcome you on behalf of the President of the Slovak Academy of Sciences to the Hall of Mirrors at the Primatial Palace for this honorary degree ceremony during which a Doctor of Science degree will be bestowed upon an exceptional scientist. My name is Tomáš Hromadka. I represent the Academy here today, and I will also do my best to guide you throughout the ceremony. I am especially grateful that I can welcome our distinguished guests here, Professor Anton Zeilinger from the University of Vienna and the Austrian Academy of Sciences, and Elizabeth Zeilinger. Ladislav Kamenický, the Minister of Finance of the Slovak Republic. Their Excellencies, Ambassadors of Romania, Indonesia, Switzerland, the Czech Republic, Austria, Japan, Germany, as well as His Excellency, Slovak Ambassador to Austria. The President of the Austrian Academy of Sciences and the former Presidents of the Czech and Slovak Academies of Sciences. Distinguished representatives of Slovak universities, including rectors, prorectors of universities in Bratislava, Trnava, Ružomberok. Representatives of ministries, embassies, and other state and public institutions. Members of the Assembly, the Scientific Council, the Presidium, the Council of Directors, as well as the members of the Learned Society of Slovakia, and Martin Venhart, the President of the Slovak Academy of Sciences. Ladies and gentlemen, dear colleagues and friends, this Hall of Mirrors is a space of great historical significance, and the gatherings of the Slovak Academy of Sciences held here add new chapters to the rich legacy of this place. Representatives and guests of the Academy usually assemble here for a singular purpose, and that is to celebrate science, the most powerful means of understanding the world. And today is no exception. We are here today to recognize exceptional scientific achievements of an outstanding scholar who will receive the Honorary Doctor of Science degree from the Slovak Academy of Sciences. And now I would like to invite Martin Venhart, the President of the Slovak Academy of Sciences, to deliver his address on behalf of the Academy.
Dear Professor Zeilinger, dear Madam Zeilinger, dear Minister of Finance of Slovak Republic, dear Excellencies, distinguished guests, dear colleagues, ladies and gentlemen. Today we gather not merely to celebrate an individual achievement, but to recognize a scientist whose work has fundamentally transformed our understanding of reality itself. Professor Zeilinger's groundbreaking experiments in quantum mechanics have taken us beyond the theoretical realm into empirical demonstration of phenomena that challenge our everyday intuitions about the nature of the universe. His pioneering work on quantum entanglement and quantum information has not only validated the most profound predictions of quantum theory, but has opened entirely new frontiers in science and technology. What Einstein famously called spooky actions at a distance has, through Professor Zeilinger's elegant experiments, become demonstrable scientific fact. This work has a major impact to many other fields of science. As a very illustrative example, I would like to mention here the existence of the Hoyle state in the carbon-12 nucleus. It is a nuclear excited state which is directly responsible for possibility of formation of the carbon in the universe. Without it, carbon would not be created, and without carbon, there would be no heavier elements. And without them, there would be no Earth and no us. So look around, whatever you see, including yourself, once in the universe went through the Hoyle state. The Hoyle state is affected by entanglement with other structures in the same nucleus, bringing it to the right energy which is needed to form the carbon. Therefore, the foundation of understanding the entanglement laid by Professor Zeilinger helps us to understand our own origin. Professor Zeilinger exemplifies the highest standard of scientific inquiry. His work represents very rare synthesis of theoretical depth and experimental ingenuity and philosophical clarity, and he has consistently pushed the boundaries of what we thought was experimentally achievable. The 2022 Nobel Prize in Physics recognized this extraordinary contribution to our understanding of quantum mechanics and its practical applications. Yet for those of us in the scientific community, Professor Zeilinger's impact has been long evident in the thousands of researchers he has inspired, in the new fields of quantum computing and quantum cryptography that his work has enabled, and in the fundamental questions about the reality that he has helped us to answer. By a distance, Vienna and Bratislava are two closest capitals in Europe and second to closest in the world. Unfortunately, for a significant fraction of the 20th century, they were separated by the Iron Curtain. Major societal changes at the end of the 80s in Czechoslovakia dismissed these boundaries, making the collaboration between Professor Zeilinger and Professor Buzek from the Institute of Physics possible. These possibilities were even enhanced in 2004 when Slovakia became a member of the European Union. These two events made the collaboration between Professor Zeilinger and Professor Buzek the most illustrative example what can be achieved in democratic, free, open, and unified world and society. The quantum technologies emerging from Professor Zeilinger's research promise to revolutionize communications, computing, and cryptography. Yet he pursued these discoveries not only for their applications, but to answer fundamental questions about the nature of a reality. This is the essence of the basic research and a principle that guides our own academy's mission. It is the basic research that drives innovations. Professor Zeilinger, we are deeply honored by your acceptance of the honorary doctorate of the Slovak Academy of Sciences. Your work illuminates the path forward for physics and for the science. We are very proud on the results that were achieved in your collaboration with Professor Buzek, and we look forward to continued collaboration built upon foundations you have laid. On behalf of the Slovak Academy of Sciences, our entire scientific community, and also on my personal behalf, I really congratulate you for all your achievements, and I thank you. Professor Zeilinger, please welcome to the community of honorary doctors of the Slovak Academy of Sciences.
Thank you. We are also honored to welcome Professor Vladimir Buzek from our own Institute of Physics to deliver the laudation for Professor Zeilinger. Please join me in inviting Professor Vladimir Buzek to the stage.
Distinguished guests, colleagues, friends, and family, we gather today to honor a lifetime of remarkable scientific achievements and to celebrate a man whose work has reshaped modern physics and profoundly inspired our community. It is my great privilege to deliver this laudatio for Professor Anton Zeilinger. Professor Zeilinger stands among the most influential physicists at the turn of the 20th and 21st centuries. He has dedicated his entire professional life to revealing the mysteries of the quantum world. Guided early on by his mentor, Professor Helmut Rauch, he embarked on pioneering investigations of quantum phenomena, first with neutrons in crystals and later in revolutionary experiments with entangled photons. His accomplishments are numerous. Some of them were mentioned by the president of the Academy, but let me just briefly highlight a few. He discovered three-particle entanglement, providing one of the most striking demonstrations of quantum non-locality. The Greenberger, Horn, Zeilinger states have become foundational to quantum information science and quantum computing. He achieved the first ever experimental realization of quantum teleportation of an unknown state of a photon. He conceived and experimentally verified entanglement swapping, a cornerstone of quantum repeaters essential for future quantum Ethernet infrastructure. He led long-distance quantum communication and loophole-free bell tests, confirming the non-classical nature of reality. He demonstrated quantum cryptography using entanglement, and he has implemented numerous optical quantum computing operations that shape our technological future. In recognition of these groundbreaking contributions, the 2022 Nobel Prize in Physics was awarded to Anton Zeilinger, together with Alain Aspect and John Clauser. And here I quote, for experiments with entangled photons, establishing the violation of Bell inequalities, and pioneering quantum information science. Anton Zeilinger was born on May 20th, 1945, in Ried im Innkreis, Austria. After completing his studies at the University of Vienna, he defended his dissertation, Neutron Depolarization in Dysprosium single crystals, under supervision of Professor Rauch, and continued his research at the Atom Institute of the Vienna University of Technology. From 1977 to 78, he worked at MIT with Professor Clifford Schall, later recipient of the Nobel Prize. In 1990, he moved to the University of Innsbruck, where he performed a series of landmark experiments that fundamentally transformed quantum physics. Since 1999, as a professor at the University of Vienna, he has helped establish the city as a world center for quantum research. With over 550 publications and premier journals such as Nature, Science, and Physical Review Letters, and with citation metrics placing him among the top 1% scientists worldwide, his impact on science is truly exceptional. His list of distinctions is extensive and illustrious. Just to mention a few, the Nobel Prize, the Wolf Prize, the King Faisal Prize, memberships in numerous academies across the globe, and here, proud to mention his honorary membership in the Learned Society of Slovakia. But Professor Zeilinger's significance reaches far beyond the laboratory. He's a public intellectual, a passionate advocate of peace, democracy, and human dignity. He promoted dialogue between science and spirituality alongside with Walter Turing. And as the president of the Austrian Academy of Sciences, he pursued both transdisciplinary cooperation, bridging the natural sciences and the humanities. His love for arts is well known, from concerts at the Musikverein Wien to his participation in Documenta 13 in Kassel, where one of his quantum optical experiments was displayed as a work of art. Anton Zeilinger has been an enduring supporter of Tibetan independence, a commitment that grew into a personal friendship with His Holiness, the 14th Dalai Lama. Professor Zeilinger also played an instrumental role in advancing science in Central Europe, especially here in Slovakia. Even before 1989, he collaborated with Czechoslovak physicists, and from the mid-1990s onward, he actively supported the development of quantum optics in Slovakia. His help was crucial in establishing the Central European workshops on quantum optics, a tradition born at the Slovak Academy of Sciences that continues today across Europe and in fact beyond. Allow me to share one personal story that reflects his optimism, humanity, and sense of humor. In the year 2000, after an excellent workshop on quantum optics at Balatonfüred in Hungary, organized by our friend József Jansky, I drew Professor Zeilinger, together with my mentor, Sir Peter Knight of Imperial College, and Professor Mark Hillary, my long-standing collaborator of the City University of New York, back from Hungary toward Vienna. We stopped in Bratislava for lunch, and then attempted to cross the border into Austria, only to be turned back at one crossing and trapped in a long queue at another. Frustrated, I muttered that it would take more than 20 years before Slovakia would join the European Union and we would cross borders freely. Anton, sitting in the front seat, turned to me and said cheerfully, "I bet you a box of champagne it will happen much sooner." At this point, Sir Peter chimed in from the back seat, saying, "Vlado, take the bet. This is a win-win situation. Either you get champagne or you get Europe." Well, just 4 years later, on May 1st, 2004, Slovakia entered the European Union. That evening, I hosted a celebratory dinner in Bratislava for our whole crew from the journey. Anton received the promised box of sparkling wine, and in return, due to his generosity, he presented me a box of exquisite Austrian wine and a book, The Habsburgs, Embodying Empire, by Andrew Wheatcroft, and simply saying, "Welcome back." That moment I will never forget. Over the years, Anton Zeilinger visited our research group many times, and one of the most significant milestones was the first ever international quantum cryptographic link connecting two countries established in 2005 during the celebration of Einstein's Annus Mirabilis. This was also a memorable event. 50 physicists running back and forth across the Austrian-Slovakian border, which once formed a part of the Iron Curtain. That was really an amazing experience. Anton's support continues to pay off today. In recent years, secure quantum links have been set up between Vienna and Bratislava. Last month, a quantum link was established between Prešov and Košice, and just this week, a new link using technology developed by Professor Zeilinger became operational between Trnava and Bratislava, with more to follow soon, ultimately connecting cities across the whole country. Just a few days ago, the Institute of Physics of the Slovak Academy of Sciences signed a memorandum with the Office of the President of the Slovak Republic to begin establishing quantum-secured communication among the highest state institutions. This entire development, this new quantum future for Slovakia, traces its origin back to the inspiration and support of Professor Zeilinger. To conclude, for his scientific vision, his global influence, and his indispensable role in development of physics in Slovakia, it is both fitting and deeply deserved that the Slovak Academy of Sciences awards Professor Zeilinger the honorary scientific degree, Doctor of Sciences, honoris causa. Dear Anton, on behalf of all us in Slovakia, thank you for your friendship, your leadership, and your unwavering belief in what we can achieve together. Congratulations. And welcome once again back to Slovakia, which is part of Europe for the time being. Thank you very much.
Ladies and gentlemen, I'm honored to declare that the Scientific Council of the Slovak Academy of Sciences, in recognition of outstanding scientific contributions to particle physics and quantum technologies, confers the degree of Doctor of Science in Physical and Mathematical Sciences, honoris causa, to Professor Anton Zeilinger from the University of Vienna and the Austrian Academy of Sciences. And now I would like to invite the President of the Academy back to the stage to present Professor Zeilinger with the honorary degree of Doctor of Science of the Slovak Academy of Sciences. Professor Zeilinger, please join us here on the stage. And now with the degree conferred, the diploma presented, the flowers stored safely on the table, I would like to invite Professor Zeilinger back to the stage to deliver his lecture and perhaps personal remarks. Professor, the floor is yours.
Dear Mr. President of the Slovak Academy of Sciences, Your Excellency, the Finance Minister of Slovakia, who I learned is a trained physicist, and in my eyes, trained physicists make the best politicians. I'm not saying anything negative about the others, but trained physicists, because physicists know how to make decisions taking into account all the evidence. I think that's certainly a good characterization of physicists in my eyes, but subjective. Dear colleagues, former presidents and presidents of other academies, with many of whom I had many contacts over the years. I still remember my participation in the Venhart discussions as a kind of a guest from Austria, and many other occasions of that kind. I've been asked to reflect a little bit on, from my eyes, about my scientific career, and I would like to do that a little bit. The first thing you should know, and I don't know what your conclusion would be about that, is that in my whole academic education at the University of Vienna and a little bit at the Technical University of Vienna, I did not go even a single hour to any course of quantum mechanics. No lecture, no seminar, nothing, no, absolutely. And when it turned out that I was about to, I worked on a PhD thesis with Helmut Rauch, who I'm sure only few of you know, but he was a real pioneer in foundations of quantum mechanics. Today, some of his achievements are actually automatically used in the development of quantum information concepts and so on and so on. I did my thesis with Helmut Rauch on a neutron, not scattering, but a neutron depolarization experiment, which for the physicists today, in hindsight, must have been one of the first experiments in the world on decoherence of matter waves due to interaction with a partly chaotic system. That language didn't exist then, and we didn't describe it that way, but in hindsight, that was the case in my eyes. And Helmut Rauch, I would mention a little bit about him. He was a very good teacher in the sense that in the seminars, I was always sitting in the last row, he was sitting in the first row, and we two were fighting. We're fighting about this and that in physics and so on. And that is an ideal academic teacher. He respects you even as he does not disagree with you physically. So, as I said, Helmut Rauch was really somebody very, very special for me. Unfortunately, he passed away 2 years before I received the Nobel Prize. The second person I would like to mention, physicists know him, was a person called Horn, who produced the first quantitative, together with others, quantitative predictions for experiments testing Bell's inequality, testing entanglement. I met him at MIT, it was already mentioned, where I also worked with Cliff Schall, who introduced neutron diffraction in the late 40s, and who received the Nobel Prize in the 90s. That is actually, if you look at there was an article a while ago That's actually what the most, statistically, the most important correlation, strongest correlation to win the Nobel Prize is that you have worked with a Nobel Prize winner. That's very interesting, because when you work with a Nobel Prize winner, very often you get another view of the things, you know, you get openness and all these kind of things, you know. So that was the case for me too. And I'm looking forward to the first of my students getting the Nobel Prize someday. You never know. So anyway, see, this was the beginning with Helmut Rauch, working on neutrons. And then I went to MIT, worked there with Horn, and he had done some key work on entanglement. And when I read these papers for the first time, I did not have the foggiest idea what was going on. I did not understand it. Not just mathematically, yes, but I didn't understand it. I didn't understand what was going on. And I told that to Mike Horn, who was a pioneer, and he said, "Welcome to the club of people who don't understand what's going on here." And in the end, I wanted to do such experiments. I was asked to explain how I became working on this. I became interested to do such experiments, and it turns out that neutrons, which you get from nuclear reactors and so on, the intensity is much too weak to get quantum correlations. So I had to switch to photons. Very simple. And this coincided with we had some theoretical work already, but experimentally it coincided with my becoming professor in Innsbruck. And the big advantage in Innsbruck was that before they already have some other predecessors who were on the chair, left again very soon. They didn't like it there, didn't think they got enough money or whatsoever, which put me in the fantastic position that I got a lot of money. Because, you know, they didn't want this to happen again. And there I decided to start to work on photons and entanglement. And I still remember on the conference in 1990 in Copenhagen, there was also Harald Weinfurter. He was another student of Helmut Rauch, neutron guy. And I asked him, do you want to join me? I want to work on photons, quantum entanglement, and so on. And he said, yeah, but I don't even know how a laser really works. And I said, theory, yes, but practice. And I said, you know, that's a problem. We have to learn that. So we switched together, we switched our fields. And that was an extremely successful collaboration. You mentioned the details already. And the rest is more or less history. The rest is written down, can be seen anywhere, what has happened, and so, et cetera, et cetera. One thing I would like to actually mention here, it is interesting to see the applications coming up, quantum cryptography, et cetera, et cetera. There, the big challenge, as you know, is to get data rates, which are useful for the internet. So this, in my eyes, is the biggest challenge there is, and actually nobody has a real good solution. So that will be interesting. It's only kind of a niche thing for very high security things, but not for common communication. And if I want to say something about the hype of quantum computation, which is a very big hype right now, I'm not sure. I'm not sure if we will have a quantum computer within 20 or 30 years or whatever. The challenges are so enormous, and there are too many promises around. I say this quite openly. There are too many promises around, and we will see what happens. Anyway, but something will happen. Something will happen because when you compare the invention of the laser, one of the guys, Kirby, who got the Nobel Prize for it, No, that was not a laser. That was micro-optics, microchips. The first microchip, they had they had very few transistors. I don't know, very few. And the idea was whether this can be expanded to a very big microchip with thousands of transistors. And at that time, there was an argument that transistors are failing so much that it's completely irrational to claim that there will be a computer chip. Second argument was nobody knows anything we can do with it. Okay, which was both comments were correct at the time, but they turned out to be too narrow-minded. Maybe I'm sometimes too narrow-minded. That could all very well be. Just to mention on my connection to Bratislava again, I remember very much this car drive across the border, where I actually predicted that rather soon we will not have to show passports on the border again. And that happened. It simply happened. I also remember your workshops in Budmerice. This brought together for the first time the Eastern and members of the Western quantum optics community. They were very, they were called Central European Workshops of Quantum Optics, I think, quantum optics. And this was very, very nice to meet the guys and also to see that the wines across the border here are just the same as we have in Vienna, the same quality, etc., etc. So, again, I would like to thank the Slovak Academy for this high distinction. Thank you very much. This is very special for me. As you said, these are the closest European capitals, where I might want to make a small correction. The two closest capitals probably in the world are the Vatican and Rome. You cannot be much closer than that, you know. My son, sitting back here, actually is interested in the development of European borders and so on. And he did some very interesting investigation, and from him I learned about. And for mathematicians, the border of the Vatican is not single connected. So, separated, whatever that means. So anyway, let me get serious again. Thank you and the whole Academy again for this very nice distinction. I really appreciate it. Thank you very much.